In this video, we will be looking at the properties of indices. And so, if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. So we start the first property, that is known as the zero exponent or index. Now it says that any non-zero number of a zero index or exponent is equal to 1. So in this case, we assume that a is a non-zero number and is raised to, or it has the exponent 0. So a exponent 0 is equal to 1. So in any case, if we have 6 exponent 0, then we are going to get 1. In the same way, if you have 100 exponent 0, we are going to get 1. So how do we prove this? So this can be proven by, we are saying 100 exponent 0 is equal to 1. How did we get the 1? So we are saying that now 100 exponent 0 can be written as 100 exponent 1 minus 1. And 100 exponent 1 minus 1 is equal to 100 exponent 0. Good. So if that continues, then we are saying that in indices, if you write something like this, if you have one base and the base is raised to the exponent such that the exponent are subtracting, then it means that the base are dividing. So we can write 100 exponent 1 minus 1 as 100 exponent 1 divided by 100 exponent 1. Now we know that 100 exponent 1 is the same as 100, and so we have 100 here divided by 100 exponent 1 is 100, and so if 100 divides 100, then we are going to get 1. So therefore we can see that any non-zero number of an exponent of 0 is equal to 1. So that is the first property, and that is how it works. So we move on to the second property, and the second property says that if we have into bracket a, b, exponent n. Now this is what the second property is saying. Now we can see that the exponent is going to have an effect on the basis. So by expanding, we are going to have a exponent n and b exponent n. So we can take examples, and if we have 2 times 3 exponent 2, then we can simplify it considering the second property of indices. So it means the 2 is going to affect the 2, that is the base, and the exponent 2 is going to affect the base 3 here. So we have 2 exponent 2 times 3 exponent 2, and this can be simplified. We know 2 exponent 2 means that 2 times 2, that gives us 4, and we know 3 exponent 2 to be 3 times 3, that gives us 9, and so 4 times 9 gives us 36. Better still, we can take another example, and we can consider 5 times 4 exponent 3. Now in this example, we can see that the exponent is going to affect the two bases. So with the first one, we have 5 exponent 3 times 4 exponent 3. But we know 5 exponent 3 to be 125 times 4 exponent 3 to be 64. So at the end, we are having 8,000. And so this is how the second property of indices works. So we move on to the next property, and we have the negative index. Now the negative index is saying that if we have a, and then a has an exponent of minus n, so that's where the name is coming from. So the index or exponent here is negative. So in simplifying this, then we can write it as 1 out of the base, that is the number a, 7 as base here. Now the exponent is now going to be positive, so we have exponent n. So in this case, such that a is not equal to 0, because if a is equal to 0, then we are going to get undefined. So in this case, this is what we are going to get. So we can take example to see how it works. So we have 2 exponent 2, 2 exponent negative 2. Now we are saying that this can be written as 1 out of the base, and now the index is going to be positive, so we write exponent 2. Better still, we can write 3 exponent negative 4. We are saying that it's going to be 1 out of the base, and then the index now changes to positive. And we can simplify this by getting 1 out of 8, 1. Better still, 1 out of 2 exponent 2 can be written as 1 out of 4. So that is how the property 3 works. So in the same way, if you have 1 out of a exponent n, we can also write it as a exponent negative 3. So we continue with the fourth property, and the fourth property is known as the power of quotient of two numbers. Now, power means an index or exponent, and the quotient we are talking about here means division. So simply put, if you have a out of b exponent n, then we can write it as, now the exponent is going to affect the a and also affect the b, and so we can write it as a exponent n divided by b exponent n, knowing well that the b is not equal to 0. If b is equal to 0, then we are going to get everything here to be undefined. So example, we can consider 2 out of 3 exponent 2. Now clearly we can see that the exponent 2 is going to affect the base 2 here, and we can write it as 2 exponent 2 divided by, now the exponent 2 is also going to affect the base 3, and we have 3 exponent 2, and thus we have 2 exponent 2 is giving us 4, and 3 exponent 2 is giving us 9. And so in case we have x out of m exponent 3, then we can write it as x exponent 3 divided by m exponent 3. So that is property 4 of indices. Now we continue with property 5, and property 5 says that the negative power of quotient of two numbers. So in this case, we are looking at the index being negative and then the numbers being divided. So simply put, then we have a out of b exponent minus n. So that's the negative index we are talking about, and then the quotient, the numbers being divided. So in this case, to simplify it, then we have to take the reciprocal of the numbers here. So the reciprocal means that we are going to write b as the numerator here, and then a is come to serve as the denominator. If that happens, the index is going to change and become positive, and so we have exponent n. So example, we can consider 2 out of 3 exponent minus 2. Now in this case, to simplify this, provided the index is negative, we are going to take the reciprocal of the two numbers here. So we have 3 out of 2, and now the index becomes positive, that is exponent 2. Better still, we can consider 3 out of 4 exponent minus 3. Now once the index or exponent is negative, we are going to take the reciprocal of these two numbers, and we have 4 out of 3, and the exponent that is negative now becomes positive, and that is what we have here. So we can further simplify this, and we have 4 exponent 3 divided by 3 exponent 3, and at the end 4 exponent 3 is known to be 64, and 3 exponent 3 is known to be 27. We can also simplify this, and we are going to have 3 exponent 2 divided by 2 exponent 2, and we have 9 out of 4. So that is the fifth property of indices. Now we continue with the next one, and we have the fractional exponent or index. So in this case, we are concerned about the index or exponent that is being a fraction. So it means if you have a as a base, it has an exponent that is a fraction known as 1 out of n. Now in this case, if a is any real number and n is positive integer greater than 1, then we can write this as the square root or the nth root of a. So the nth root of a. Now in this case, if we have something like 25 exponent half, then we can write this as the square root of 25. That is, we know n to be 2 now and the a to be 25 here, and so square root of 25 is what we know as 5. Now we have something like 16 exponent 1 out of 4. Now with this, it means the n value here is 4, and so we are going to have the fourth root of 16, and we all know the fourth root of 16 to be 2, and so we have this. So we can also consider cases where you have negative 36 exponent half. Now from here we can see that we are going to have the square root of 36, knowing that the n value here is 2, that's the square root of 36. Now the minus is not affecting 36 in the square root. It should rather affect it at the back, because the square root does not cover the minus as well. So the minus is a separate term and 36 is also a separate term. And so at the end, we are going to have minus, we all know square root of 36 to be 6. So this is quite different from minus 36 all exponent half. And so let's know the difference when working with indices with fractional exponent or index. And so this ends today's video. Thanks for watching. Kindly like, comment, subscribe, and share. BakoMaths, thinking beyond infinity.